In this lesson, we will prepare to make a sheet metal part by creating a sketch using the intersect and fillet functions. We'll create a new design using the switch plate file and save it to the Tier 2 project in a new folder you'll need to create named Sheet Metal. Begin by creating a new component named Switch Plate using the top level of the design as the parent and setting the Activate option to On. We will also need to select the sheet metal component option in the dialog. Once this is selected, a list of sheet metal rules will be shown. We will leave the aluminum millimeter rule, which is the default, active, and then click OK to create the new component. In the browser, note that the icon for a sheet metal component is different than the standard block icon used for other components. To leverage the sheet metal tools, we will switch from the model workspace to the sheet metal workspace. Expanding the newly created component, we see a browser element that is unique to sheet metal components, which is the display of the active rule. We'll take a closer look at rules in another lesson. For now, we want to focus on creating features from sketches. Sheet metal components can use open or closed sketches. A closed sketch will create the face when a flange tool is used, and an open sketch will create an open body. Both will have the thickness defined by the active rule. We'll start out by creating a sheet metal duplicate of the original profile on the existing feature. We'll create an offset plane based on the XYZ plane in the origin folder and set the plane distance to 50 millimeters. Then we'll start a new sketch on this plane. Because it will be a duplicate of the existing geometry, we'll press the P key to start the Project tool, or you can select Project from the Sketch pull-down and select the top face of the part. This will project all of the edges, and you can click OK to finish the Project tool, and then stop the sketch. We'll then go to the Create pull-down and start the Flange tool. We'll select the profile that was projected. Notice that the initial selection leaves the holes open. For this component, we want a solid rectangle, so we'll make sure to select the circles and add them to the feature. With the new feature complete, I'll rotate to the front view and see that the thickness of the sheet metal is on one side. You can choose the thickness to appear on either side of the part, or choose symmetric for the thickness to be generated on both sides of the sketch equally. The important thing is that we are not having to define what the thickness of the feature is, as it is controlled by the rule. We will leave this featured as previewed and click OK. Then rotate the model to see what the result is. With that feature complete, expand the Bodies folder in the browser and turn off the visibility of the new body. Now, we'll right-click and create a new sketch on the YZ plane of the component. Then, looking directly at the sketch, we'll start the Project Intersect tool. Rotating the view, you can use the Intersect projection to select the face on the side and get the geometry of the face at the intersecting plane. I'll start the Line tool and pick the bottom point of the projected edge and move my cursor straight up. Then click to create the segment and move the cursor to the right until we see that it is directly over the other projected edge. Then click again, and then select the bottom point of the second projected edge. We can get a better look at the sketch by selecting the right face on the view cube and then start the Sketch Dimension tool. We'll place a dimension between the top line of the sketch and the top face of the existing part. We'll set the value to 50 millimeters and notice that by selecting the top face, Fusion 360 projected another edge, creating a closed profile. We'll finish the sketch and again start the Flange tool. I could select the closed profile to create another face, but instead I want to select an edge of the open sketch and then drag the arrow to see that it's developing the material thickness on all three edges of the sketch at the same time to the distance that I drag. We can use the Symmetric option that adds material in both directions from the sketch plane and rough in the distance. Then we'll take a look at the right side of the component again. From this viewpoint, you can see the thickness of the material is being developed and the bend is automatically being added to the corners. The radius for this bend is also established by the active sheet metal rule. Let's set the final value for the distance to 125 millimeters, which is the value for one side, so the overall length will be 250 millimeters. Then click OK to create the new sheet metal body. Restoring the visibility of body 1 shows that the two bodies nearly overlap except for the bend automatically added to body 2. After reviewing this, I'll turn body 1 back off again and take another look at the sketches we used to create the two bodies. Because the first sketch was a completely closed profile, it created a single face that followed the same profile at the material thickness. The second sketch included edges that were not limited to a closed face, so we were able to create an extruded feature that automatically added bends to the profile. As I mentioned before, these bends were automatically calculated based on the sheet metal rule. However, if we edit the sketch and use the fillet tool to add fillets to the corners with a radius of 15 millimeters, when we stop the sketch, it will cause a temporary error in the second flange feature. To fix this, right-click on the feature and select Edit Profile Sketch. You'll see only one edge of the original profile is still selected, so we can remove the selection from the Edit Feature dialog and then pick an edge of the updated profile for a new selection. This will generate a preview of the new feature, and clicking OK, we can see the updated shape, which includes the sketched bends. This is still a completely acceptable sheet metal body, which can be unfolded or have any other operation the previous version had available. It just uses the sketched profile instead of the radiuses built into the rule. This gives you the ability to pick and choose how a bend in a corner will be defined. Returning to Sketch 2 to edit it, we can change the radius value from 15 to 5 millimeters, and when the sketch is stopped, the feature will update reflecting the new radius without the need to reselect the profile. This is because while the size of the radius might have changed, all of the same elements were kept in the sketch. Now, save the file and prepare for the next step.